Okay, let's look at how arithmetic is performed in NumPy arrays. So we have, say, ARR1 is NP array, and let's keep it simple. Okay, so it's a two-dimensional array. In the first dimension, we have two lists, 1, 2, 3, and 4, 5, 6. Okay. And then we have another one, ARR2, and it also has the same dimension and shape. So 7, 8, 9, and 10, 11, and 12. Okay. Okay. I need to give this as a list. There must be a single list, but I gave two lists. That is the problem. So I have to nest the lists within another list. So I need to. Okay, so that's the list, and within that one list, I have two lists. Okay, so there you go. So let's use print so it'll look. Okay. So now the dimensions are exactly same, and when I use ARR1 plus ARR2, then okay, if you're using base Python, then what that will do is it will take the one list. When you add another list, it will just simply concatenate the two lists. But here in NumPy, it matches the elements and adds them, iterating over the entire list. So you don't have to do a for iteration. It's automatic in NumPy. Okay? So it matches 1 with 7, gives you 8, 1 with 10, 4 with 10, 14, and so on. And 2 and 8, 10, 5 and 11, 16, and so on, right? Now we can do ARR1 minus ARR2, and that will do the minus, the subtraction. Okay, and we can do ARR1 times ARR2. So that will match up the values and multiply. Okay, and we can even do something like this. 1 divided by ARR1, so that will give you that. Okay. Now if you want to round, so make the division within parentheses and then say round, say 4. That will round the numbers up to 4 decimal places. Okay. Now what about the case when the shapes are not the same? Okay. Like for example, ARR1 is NP array 1, 2, 3, okay, and then ARR2 is NP array. Okay, so now I'm going to have 3 elements in 2 dimension. So I have to have a list inside the list. So 7, 8, 9 is one element, then 10, 11, 12, 13, 14, and 15. Okay. So that is ARR1 and this is ARR2. Okay. So the shapes are not the same. Okay. When the shapes are not the same, NumPy does what is called broadcasting. So if you do ARR1 plus ARR2 and sees that ARR1 is of smaller size than ARR2, and we will talk more about this in Pandas. Okay, so it's going to broadcast, and there are some rules that for broadcasting. We will talk about that later. But for now, you need to understand that the smaller, the one with less dimension, ARR1 has only 1 dimension. ARR2 has 2 dimensions. So it will expand the dimension, it will copy the same values in the other dimension. So it will create, ARR1 will expand in this fashion to match the shape of ARR2, and then the addition will take place. Okay, and same is the case with, suppose we go ARR2 minus ARR1. Okay. Once again, ARR1 is expanded to match the shape of ARR2, and then the operation is performed. Okay. And then there are functions. Okay, if you look at table 4.4, you see the functions. So each of these, addition, subtraction, multiplication, can also be done with these functions. So np.add ARR1, ARR2. Okay. So that will add the 2 functions. Okay. Okay, so here, so if you do divide, then we have division and div mod, division modulus, and so on. So ARR1, ARR2. So it will match up the elements and divide ARR2 into ARR1. Okay. And we can also do this. Okay. If you do this, then you will get a Boolean NumPy array, where when it will now match up again, it will broadcast, make sure that the 2 arrays are of the same size, and then match up elements and apply the condition. If the condition is true, you will get true, otherwise false. Of course, the first one is 1, 2, 3, so you're going to get all false.